Okay, so now we are going to start looking into area. So, area of shapes, and we're going to start with one of the easier shapes, which is a quadrilateral, a four-sided shape. So, when we talk about area, we're essentially talking about the total space taken up by a flat, plain 2D object. So, plane and 2D sort of mean the same thing. It's essentially just we're looking at this from, say, a bird's eye view, this rectangle, and we're just looking at sorry, the total space taken up by it. So kind of we call it the area enclosed within a shape, or essentially the space within this shape. So kind of shading all of all of this bit within it, going towards all the borders and etc. etc. So we're going to start to investigate this in this video. So here I have a 4 by 3 meter rectangle. So we have two dimensions. We have a length and I should say a length and a width. One of these being 3 meters, one being 4 meters. And we want to just find out the space taken up within here. So a nice easy way to think about this is, well, let's break up each of these dimensions into, I'm going to call them little unit squares. So by unit, I essentially just mean one meter, the unit being one. So I'm going to break first our width. Let me actually do it this way, into 4 equal bits, each here being 1 meter, 1 meter, 1 meter. Oh, that's so messy. 1 meter and 1 meter. Now let's break up this one as well into 3 unit squares. And I know this doesn't, it's obviously not to scale, so it's not going to look the best, unfortunately. But here we have this dimension now as 1 meter and 1 meter. So each of these here, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 of these squares, 1 meter by 1 meter, making up our total area. And this essentially gives us the space within our shape. Now, how do we get the 12 here? Well, we also could have said, well, we have a dimension of 3 multiplied by a dimension of 4 meters. And this is essentially the definition of area. This is how we define this region's size on a surface. We broke this up into units, and that essentially showed us that we could multiply these two dimensions together to give us the area of our shape, the size of this particular rectangle. So to formalize this, I'm going to say our A for area equals to the product of the two dimensions. So here 4 was our length. So we say our length multiplied, the 4 was our width. So our length of 3 multiplied by our width of 4. And in this case, we had 3 multiplied by 4. And we got 12 here. Now, the units we use, so by unit, I mean this little thing here. So we used meters for our straight line distance. But when we look at area, we write this because we're multiplying our two dimensions. Sorry about that. Because we're multiplying our two dimensions, their lengths, we also multiply the actual unit. So, oops. We multiply the actual unit. So here we have meters, here we have meters, and we end up with meters squared. So I also should have written here, we have 3 meters by 4 meters. So that is essentially our area. We can define this distance, well, sorry, not this distance. We define this size of a region, the size of our rectangle here, as the product of its two dimensions. In this case, it was 3 by 4. And multiplying both the distances as well as their units of meters, we get 3 by 4, which gives us 12. And meters by meters, we write this as meters squared. So that is the area of the simpler quadrilaterals. So a rectangle is one example, and also a square would give us a square of, say, let's say these are 5 by 5. So we have 5 meters by 5 meters. This will also, multiplying these two, will give us our area. So in this case, our area is 5 meters by 5 meters. It's very messy, sorry about that. 5 meters by 5 meters, and that gives us 25 meters squared. So these are I'll leave it here with these two more simple quadrilaterals. So we have a rectangle, and a square. We will look at a couple of other quadrilaterals in future videos. This is just to give you a light introduction into the study of area in measurement.